This is section 3.3, sum and difference identities for cosine. In class, I'm going to be sharing with you where these two formulas are coming from, the sum identity for cosine and the difference sum identity for cosine and the difference identity for cosine. And it has to do with the formula you saw in Algebra 1. Let's go to the next slide. Okay, this slide is going to talk about the cofunction identities, wherever those are. But before I do that, let me look at this picture that we're going to be using. Notice that I have a right triangle. This is the 90-degree angle. And this angle here is an acute angle, and this angle here is another acute angle. And notice that I'm labeling the sides x, y, and r. So from here, where does this pi over 2 come from? Pi over 2 minus u. This work with degrees, so this will make a little more sense. So let's say that this is 10 degrees. This angle, you know, is going to be 90 degrees minus 10 degrees, which is equal to 80. Now, see how I did 90 minus the angle 10? So instead of working with degrees, now I'm working with radians. Pi over 2 minus the other acute angle. That's why you see this expression here, okay, for this angle, the other acute angle. So now that we know that, let's look at this. These are the cofunction identities. I'm just going to go over this one, and then in class I can clarify the other ones if you like me to. So all I'm going to do, I am going to be looking at cosine of u. If I'm looking at cosine of u, I'm looking at the triangle from this reference angle. And definition of cosine is adjacent over hypotenuse. That's why I have x over r. Now I'm going to be looking at sine of pi over 2 minus u. So this is my reference angle now. So definition of sine is opposite over hypotenuse, which is x over r. And again, notice that these two ratios are equal, so we can conclude that these two expressions are equal. And that's what this cofunction identity is explaining or going over. So now let's go over this cofunction identity here. So first I'm going to be looking at cotangent and using this as my reference angle. And as you can see, is the adjacent side to the reference angle over the opposite side, so it's y over x. Now tangent of u, so now this is my reference angle. Definition of tangent, opposite over adjacent, so that's why you see y over x, just like the first cofunction that I went over. These two ratios are equal, and thus these two expressions are also equal. Let's go to the next slide. So here's number one. It says use the appropriate identities to find the exact value of each expression, and we're looking at cosine of 165. If you pull out your unit circle, you're not going to be able to find 165 as one of those special angles that we have seen from the unit circle. So we're going to have to apply a formula that you have seen early at the beginning of this video to be able to compute that. In class, I'll go over that, but I'm going to do number 2 in this video. So here we go, cosine of negative 5 pi over 12. And again, 5 pi over 12 or negative 5 pi over 12, you're not going to be able to find that radian measure on the unit circle. It's not one of those special, you will find it, but it's not one of those special angles. You can actually compute this, but you will need the calculator, and it's not going to be an exact value. Anyway, let me continue. You should be able to see that 5 pi over, well, I'm going to be using this formula, the sum identity for cosine, and you'll see how in just a little bit. You should be able to see that cosine of negative 5 pi over 12 is the same thing as cosine of negative 75 degrees. And again, negative 75 degrees is not one of those special angles in the unit circle. I'm going to use another fact that you have learned on an earlier section, the fact that cosine is even. So instead of computing cosine of negative 75, I am going to compute cosine of positive 75, because I'm applying this principle that you see here, the fact that cosine is even. So now, this is what I'm going to do. Cosine of 75 is the same thing as cosine of 45 plus 30. And the sum of these two angles equals 75. I can do that. And you should notice that these two angles, 45 and 30, are angles, special angles in the unit circle. Once I'm here, I should be able to apply this formula. I expand, and this is what I get. Cosine of 45, cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And that's why you see cosine of 45, cosine of 30, minus sine of 45, sine of 30. So at this point, all I'm going to do is I'm going to be computing cosine of 45, cosine of 30, sine of 45, sine of 30, using the unit circle. And you should know where these values are coming from. At this point, I'm just going to simplify, do some operations here. And this is my final answer. And notice that I cannot simplify this any further. And cosine of negative 5 power over 12 is equal to this exact value. Let's go on to the next line. So here's number 3. It says simplify each expression by using the appropriate identities, and of course no calc. So what I'm giving you here is I'm actually giving you the expanded version of one of the identities that you saw earlier. Namely, I'm giving you, this is the expanded version of the left side here. So what I need you to do, what we are going to be doing, since I give you this, you need to give me the left side. Notice that this is like your alpha, this is like your beta, alpha, beta. So what is this equal to if I want the left side, given they're using this identity? You're looking at cosine of pi over 3, which is here, minus, because this is a plus, this is a minus, pi over 4, and all you're going to do is you're going to apply a little bit of pre-algebra here, and you end up with cosine of pi over 12. And we're done. We're not going to simplify this any further in this problem. Let's go to number 4. Same idea. I give you the expanded version. You need to give me the left side. So from here, before I do that, I am going to use the fact that cosine is even and sine is odd. Okay, and I'm going to apply that here and here. So I can write the following. This became just cosine of 3 degrees, and this became negative sine of 3 degrees. What I'm going to do with this negative and this negative, I'm going to multiply them, and it's going to become a plus. Now from here, I am going to be using this same identity that you see here. So this is like your alpha, this is like your beta, alpha, beta. So the answer is going to be cosine of 12 minus 3, and I simplified 12 minus 3, which is equal to that. And this is the answer to number 4. You don't go any further. Let's go on to the next line. So here's number 5. This is going to be a little bit different. It says find the exact value of cosine of alpha minus beta if sine of alpha is that and cosine of beta is that, with alpha being in quadrant 2 and beta being in quadrant 4. So this is what we're going to do. I need to find this, which is I'm using the identity, and this is what I get. From here, I'm going to highlight the given information, sine of alpha, cosine of beta. So the first thing that I'm going to do, notice that I know what sine of alpha is. It's given there, cosine of beta, which is right here. But I do not know cosine of alpha and sine of beta. So I need to find that with the given information. So from here, first I'm going to find cosine of alpha. So to find cosine of alpha, I am going to use this information. Sine of alpha is equal to this, and that alpha is in quadrant 2. From here, I should be able to draw the following right triangle and use the reference angle of alpha prime. So definition of sine is opposite from the angle to over the hypotenuse, and that's what you see here. Applying the Pythagorean theorem, I know that this is 7. Now from here, should be able to find cosine of alpha. Let's keep in mind that cosine is negative on the second quadrant. So then I have cosine of alpha is negative, the adjacent side over the hypotenuse. So now I know cosine of alpha. So now I need to find sine of beta. And I'm going to apply a similar process that I used here. Given the information with angle beta, so cosine of beta is equal to 8 over 17, beta is in quadrant 4. So again, just like on this part of the problem, I'm going to use definition of cosine, which is adjacent over hypotenuse, and I'm going to draw this right triangle, and I'm going to be using the reference angle beta prime. So from here, applying the Pythagorean theorem, I get 15. And definition of sine is opposite from the reference angle over the hypotenuse, so it's 15 over 17. But again, beta is in quadrant 4, and sine is negative in quadrant 4. That's what I get, a ratio of negative 15 over 17. At this point, we're not quite done. All we need to do is substitute all the trig functions given the angle in here. And this is what I get. I do a little bit of pre-algebra here. Simplify. Multiply, I get negative 56. I multiply, I get negative 360 over 425. A little bit more pre-algebra. And this is my final answer to number 5. Let's go on to the next problem, but I'm going to be skipping number 6. Let's jump to number 7. So here's number 7. This is an identity, so we just need to verify one side is equal to the other. So I'm going to be working on the left hand side. I am going to be applying the following identity in the numerator. And notice this pattern. When this is a sum, the sign between these two expressions is a minus. So once I expand the numerator, this is what I get. Bring over the denominator. At this point, I'm going to give each of these terms in the numerator its own denominator. So this is what I get. And notice that this is just equal to, let me use a different color, is equal to just 1. That's what we have here. And then at this point, sine of x over cosine of x is tangent of x. Sine of y over cosine of y is tangent of y. It brings down the sign. So the left side is equal to the right side. We're done with number 7. Let's go to number 8. So here's 8. I am going to be working with the left side. Before I do that, notice that cosine of x plus y is, I'm going to be applying this identity again. For the denominator, I am going to be applying this other identity. And again, when this is a minus, this is a plus. The expression, the symbol between the two expressions here is a plus. It's always the opposite of what is here. Anyway, so let's continue. So once I expand the left hand side, on the numerator, this is what I get. On the denominator, this is what I get. From here, I am going to be applying this little trick. And now you're going to know how to use it because you have seen it. I am going to multiply this by 1. But this 1 is going to be very special. I am going to multiply by the following. And notice that I have 1 over cosine of x sine of y, 1 over cosine of x sine of y. This is equal to 1. So, which I can do. I can multiply any expression by 1. And I have not changed the original expression. That's what you applied when you were working with adding or subtracting fractions that did not have the same denominator. So let's continue. So once I multiply 1 over cosine of x sine of y times this expression in the numerator, and the same thing, this times this expression in the denominator, this is what I get. From here, I am going to apply the same idea that I used on number 7. I'm going to give each of these terms in the numerator its own denominator. This is what I get. And notice that once I have this, cosine cancel, sine y cancel, cosine x cancels, and sine y cancel. And I'm left with whatever this is. Let me just highlight it. Whatever this is, and so forth. Okay. Down here, let me just do it. And whatever this is. And notice that this is equal to cotangent of y. Notice that this is equal to tangent of x. This is cotangent of y. And this is tangent of x. Bring down the sign that is there, which is minus and plus. So all of this is equal to the right hand side, which is what you wanted to do. And this concludes video 3.2.